Biomimicry has inspired numerous innovations here on Earth. But the final frontier beckons us to look to nature once more. Here are 5 potential applications of biomimicry in space exploration.
8, 7, 6, 5.
Number 1, noise. In space aviation, noise is a real difficulty. By modeling acoustic liners after reeds, scientists at NASA have been able to dampen noise over a broad range of frequencies. 2, metal contamination. Even in space, metal can corrode. Fuel filters can get blocked up. Biofilm can grow on stainless steel. This is due in part to biological fouling, where microorganisms, vegetation, and minuscule fauna grow where they are unwanted. Looking to nature, mussels and other organisms naturally grow with ridges. It is possible that these micro-scale ridges make it more difficult for accumulation of microbes that could contaminate them. And it's possible that these textures could be recreated on functional surfaces in space. 3, brittle building materials. Many of the materials strong enough to endure the trip to space can be brittle or not have very much bend. But sometimes parts need to be a specific shape or fit into a unique location. Sometimes they have to have a little more bend. Conch shells are a unique curved shape with some impressive resistance to fractures. Modeling their curved design, we may be able to improve mechanical toughness and the longevity of parts. Number 4, ice. As aircraft enters higher altitudes, the temperatures drop dramatically, and engines can experience what is called crystal icing. Ice crystals at high altitude enter an engine's core and combine and grow, causing issues like engine stall, less thrust, and even potential damage from the ice breaking off. Animals like the Arctic snailfish, Liparus gibbus, produce natural antifreeze proteins so that they can survive in the frigid Arctic conditions. These antifreeze proteins are being studied for passive anti-icing coatings in machines. This would act as a preventative measure against the cold conditions. Number 5, dust. On Earth, dust might be annoying, but on the Moon, dust can be downright dangerous. During the Apollo missions, lunar dust did everything from clogging mechanisms to interfering with instruments, to overheating radiators. The dust can be fine and angular, almost like small pieces of glass. This can damage spacesuits, equipment, and even human lungs if inhaled. Gecko skin is self-cleaning. They have small dome-shaped scales that make it difficult for dust to stick. But when it does, they have microscopic hairs that trap water from dew or mist. This moisture eventually becomes water droplets that the spines can fling off. Currently, there is a project under development called the Gecko Roller, which works like a normal lint roller, except the outer layer is an adhesive sheet designed to copy gecko skin. Astronauts or machines would be able to use this roller to remove the insidious lunar dust.
So which of these cool examples could you see us copying or using here on Earth?